In example 4, we are going to evaluate d dx of secant inverse of 5x to the fourth. So we're going to be using our derivative rules to take the derivative of a more complex trig inverse function. Not only is secant and cosecant one of the more difficult or unusual derivatives, but it also will be involving the chain rule. So to take the derivative of this, let's recall what the derivative of just secant inverse is. So the derivative of secant inverse of x is equal to 1 divided by the absolute value of x times the square root of x squared minus 1 times the derivative of x. Now normally we don't write the derivative of x because the derivative of x is simply just 1. But I want to keep in mind that whatever goes here and here, you must also take the derivative of. Alright. So here we go. Let's take the derivative. So d dx secant inverse of 5x to the fourth. So I'm going to point out what our inside function is. It's right here at 5x to the fourth. So this is going to be equal to 1 over the absolute value of 5x to the fourth times the square root of 5x to the fourth squared minus 1. That's just applying the formula. I take the inside pieces and I put them where x goes. But here I need to multiply by the derivative of 5x to the fourth. This piece right here, this is the chain rule. Okay, now all we're left to do is do some simplifying. And I want to point out that 5x to the fourth is always positive no matter what x values I use. So no matter the x values I choose, it's always positive. So because 5x to the fourth is always positive, we then can get rid of our absolute value bars. If it was something like x cubed, we might not be able to do that. So we get 5x to the fourth times the square root. Now 5x to the fourth squared would then be 25x to the eighth minus 1 times 20x cubed. And that's the derivative of 5x to the fourth. So this will then equal 20x cubed divided by 5x to the fourth times 25x to the eighth minus 1. Then we can do a little simplifying. 1 and 4. And this goes down to 1. So that's going to leave us with the answer of 4 divided by x times the square root of 25x to the eighth minus 1. And that's it. There's the derivative of secant inverse. I think the hardest part about these problems is just remembering the formulas. I really highly recommend using flashcards. Alright. So I want you guys to try this one on your own. Take the derivative of cosecant of 1 over x where x is between 0 and 1. So again, the derivative of cosecant inverse where x is between 0 and 1. Alright, let's go ahead and take the derivative just to make sure you got it right. So let's recall what the derivative of cosecant inverse is without having anything crazy in the middle. So the derivative of cosecant inverse of x is equal to -1 divided by the absolute value of x squared minus 1 times the derivative of x. Okay, so we're going to get the derivative of cosecant inverse of 1 over x is then equal to -1 divided by the absolute value of 1 over x times the square root of 1 over x squared minus 1 times the derivative of 1 over x. So now let's do a little simplifying. We get -1 divided by, now our domain is between 0 and 1. So again, x is always positive, so I can just drop the absolute value bars. If that's not in the domain, you cannot get rid of the absolute value bars. Times the square root of 1 over x squared minus 1. Now I'm going to do a conversion of 1 so I can add my fractions in the next step. So I'm going to write this as x squared divided by x squared. And then the derivative of 1 over x is -1 divided by x squared. Okay, so we get a -1 and a -1 makes 1 divided by 1 over x times x squared over 1 times the square root, and again this x squared came from right here. It's in the denominator, but this 1 over x here is a fraction within a fraction. We get 1 minus x squared divided by x squared. So we get 1 divided by x times the square root of 1 minus x squared divided by x. So from here, we're going to notice that these are going to cancel, and we get 1 divided by the square root of 1 minus x squared. And I want you to also notice that this is equal to the derivative of sine inverse of x, which will lead into the next video, which involves calculator conversion identities. The calculator conversion identity that I will show here, though, is that d dx of cosecant inverse of x, or 1 over x, is equal to the derivative of sine inverse of x. Likewise, we get that the derivative of cosecant inverse of x is equal to the derivative of sine inverse of 1 over x. And I'm going to go more into these conversions in my next video. But keep in mind that on a lot of calculators, we don't have the cosine inverse button. But we do have a sine inverse button usually. So this will be helpful when we want to convert into sine inverse.